Hello, am I audible to everyone? Okay, all right. So, yeah, okay. So we'll get started. So welcome everyone to the Maths-2 course, right? So Maths-2 Mathematics for Data Science 2. So I'll be one of the instructors for this course. So I'll just quickly introduce myself. So my name is Karthik, and I've been a part of this program, the BS program, since the year 2020. Right? So I actually joined 2020 in June. So it's like 4 years back, and I've been a part of CT, Python, Max2, Machine Learning Foundations, which is a diploma course, Machine Learning Techniques, which is another diploma course, and I've also been a part of Reinforcement Learning, which is a degree level course. Right? So these are some of the places that I've been courses, and this time I'm in Max2 again. So yeah, right. So we'll get started. So support, as far as this course is concerned, is there are two levels of support. So one is the instructor support, and the other one is the TA support, right? So I hope you're all aware of teaching assistants, right? So teaching assistants are nothing but your peers, okay? Those who are or rather your seniors who have already done the course, but have done a very good job in that particular course, right? So in this case, Max2, they have done Max2, they have done exceedingly well in the course, and subsequently they have come back to help you with your questions, doubts. Okay, so that's the role of a teaching assistant. So instructors, there are going to be 2 or 3 instructors. One is me, and the other one is I'll introduce the other person soon, maybe by the end of this week, right? So teaching assistants, there are 2 of them. One is Pranjal. So Pranjal is one of your seniors, and Giri is the other person. Some of you might have seen Giri in computational thinking if you have taken CT last term. Okay, so the 2 very good TAs we have. So this is the support for the course, and the nature of the support is going to be in the form of live sessions to begin with. Okay, so you have, so this is a bit tentative. I'm like structuring it in a certain way. So we will see how it goes, right? So what I'm planning is I'm planning to have 3 sessions, 3 instructor sessions. Right? Okay, so there'll be 3 instructor sessions, and they'll be from 3 to 4 p.m. on on Tuesday, Wednesday, Thursday. Right? This is what I'm planning, right? In fact, there will certainly be one more session. So there will be 4 sessions. Let me change this to 4. 4 sessions. 3 of them happen on weekdays between 3 to 4, and one will be from 8 to 10 p.m. on Sunday. Okay, so earlier last term, what happened was we had 8 to 10 p.m. and another session on Thursday or Friday. I don't remember which one. That was again from 8 to 10 p.m. So we had 2 sessions on 2 days from the instructors. But this time, what we are planning is I will be doing the 2, 3 sessions during the weekdays, and that will be from 3 to 4 p.m. Okay, so all of them will be streamed. So in case you are a working professional or you're doing some other degree alongside this, and you will not be available during this weird time of 3 to 4 p.m., that is fine, because you can always watch them online later on. Okay, so that is always there. So 4 instructor session and at least 2 TA sessions. Okay, so at least 2 TA sessions, because we have 2 TAs. There will be certainly 2 sessions, but there might be more. Again, the time is something we have not fixed. We have not decided upon this time, so we'll get back to you on that. So what will happen is throughout the week you will have one session or the other on a given day. Okay, so you don't have to wait for a very long time to get your questions clarified. So that's the idea, and these are the live sessions. And in terms of supplementary content, so we'll maintain what is called a master folder, and the master folder will contain the following. So it will have practice assignment solutions and graded assignment solutions once the deadline is over. We also have a textbook, okay, for the course. So the course has a textbook, at least one part of the course has a textbook prepared by instructors who have done this course in the past. Okay, it's a very good textbook, so that is available to you. So the link, even now you can find the link on the portal, but this textbook will also be uploaded to this place called the master folder, and we'll also be uploading the live session links, right? So whatever sessions we have, the links to the sessions, right? YouTube links to the session, and also you'll have the notes for the live sessions, right? Whatever notes are written down during the session, these will also be uploaded to this same folder, right? So the idea of the master folder is to have a single location where you can get most of the important resources, supplementary content that are part of the course. Okay. So far, any questions from anyone? Okay, so not we go on. So that is, so the syllabus of the course, right? So what is the course all about? So the course is divided into two parts. So the first part is called linear algebra. Okay, and that will cover the bulk of the course, right? So that will be from weeks 1 to 8. 75% of the course is going to be the subject called linear algebra, okay, which you have, I'm hoping, or no, not, so hoping is not the right word. I'm expecting most of you would not have seen this anywhere, right? Especially if you're not from a science background, you would not have seen linear algebra anywhere, but it's not that hard. All that it just takes a little more time than other courses, right? So that's linear algebra. And what is the other part? The other part is called multivariable calculus. Okay, and this occupies weeks 9 to 11. Okay, 11, 12 is, there's nothing in week 12. So week 12 is an empty week. So there are only 11 weeks in the course. Okay, and 9, 10, 11 make up what is called multivariable calculus. So single variable calculus you have seen. Okay, in Maths 1 you have seen single variable calculus. Multivariable calculus is nothing but the same ideas of, you know, this continuity, differentiability, all that extended to multiple variables, right? Functions of two or more variables. So you might have been used to this f of x, right? So f of x and f of x equal to, let's say, x into sine x. Okay, this is something that you would have seen. Here, what we'll be doing in this course in the last 3 weeks is we'll be discussing f of x comma y is equal to x plus sine x, right? So this is or rather, say x plus sine y. Okay, so functions like this. So that will be the last 3 weeks. Now, interestingly, the last 3 weeks also require linear algebra. Okay, so the last 3 weeks, even though the name is multivariable calculus, it requires a lot of linear algebra. So whatever you learned in the first 8 weeks, you can't forget it when you come to the last 3 weeks. You will be using some part of it when you come to weeks 9 and 9, 10, 11. Okay, so any questions about the syllabus? Okay. Yes, yeah, go on, Himanshu.
Sir, I have taken Maths 1 a year ago and I have forgot I almost everything. So, do I require to study all the things again, or I can bear this course?
Okay, so the prerequisites. So we discussed that in prerequisites. So what you need from Max 1 are the following, right? So what you will need from Max 1 is you will need to know basic set theory, right? So you have to know what is so what are sets, what is basic operation, right? What is intersection, what is union, what is a subset, uh, all what is a superset, all this you need to know. Okay, so this is the basis basic requirement from set theory. And you also need to know what functions are. So by that I mean you need to know when is something a valid function, what is a, so you need to know the definition, right? Of course you need to know what a function is. You need to know a bit about what is a one-to-one function. So what is a one-to-one function, what is an on-to function, what is a one-to-one and on-to function. You need to know about that. You need to know what is the inverse of a function and when it's defined. So these are all needed from the point of view of functions, because we will be looking at special class of functions in linear algebra. Okay, so this is needed. So set theory and functions are very important. You have to go back and quickly revise them.
Okay, sir. This part I can do, but later on, like week 5 or week 6, that exponentials and calculus part, I don't remember anything of that. So I do I need to revise that one also before
Yeah,
starting?
yeah. So for calculus, you need to know before you come to the last 3 weeks of this course. You need to know what are limits, what is the limit of a function, what is when is a function continuous, and when is a function differentiable. So you need
Different.
to know these three before you come to week 9.
Okay, so before week 9, I need to learn calculus.
Yes, yeah, not a lot of it because we'll slightly touch upon single variable calculus. So, but at least some idea of this is encouraged.
Okay, okay, sir. Thank you.
Okay, so that is Max 1 prerequisites. Other courses, so there's nothing else, right? So there's only this prerequisite. So there's no CT, Python. Well, Python you can, if you have done Python or if you're learning Python, you can kind of try to implement some of these algorithms in Python. That might help, but it's not a prerequisite per se. Uh,
Yes, sir.
yeah. So where does this lead to, right? So why is this course important? This course is important in terms of, at least in terms of this degree, right? So this will lead you. So when I say lead to, what I mean is where all will linear algebra be used? Okay, so linear algebra will first be used in this course called MLF. So machine learning foundations. Those of you who don't know, it's a diploma course, right? It's a course in the diploma level. It is there in the data science diploma. So there are two diplomas, right? So this is there in the data science diploma. So this is actually an advanced linear algebra course, right? MLF, what we call MLF, is actually Max-2 version 2. So that's how it is. And this will in turn get used in the course called MLT, which is again a diploma level course. Very important course in the program, entire program. So there also you will use a lot of linear algebra, and you will also use this in a course called deep learning, which is in the degree level. Okay, so this is like once you finish your two diplomas and you enter the degree, you'll end up using linear algebra. You'll also use it in what is called this course on large language models, right? So LLM stands for large language models, which is all the rage today because the chat GPT and all that, right? So they all are large language models, and they also require quite a bit of linear algebra. In fact, they are, so it's like a follow-up to this course called deep learning, but you can already see that deep learning, I said, involves linear algebra. So naturally, this course will also involve that, right? So yeah, so wherever you go, this course will the subject called linear algebra will follow you. So getting a good understanding of this course, at least the first 8 weeks, is going to be very important. Okay, so that's regarding the prerequisites and what this course means in the larger picture of the program, right? Where all its impact will be felt. So that is regarding the the prerequisite and the other aspect. So nature of the course, right? So what kind of a course is this? Of course, it is a mathematics course. We all know that because of the title. But what kind of mathematics? So there are different kinds of mathematics. Okay, so that some of you may have encountered, some of you may not have come across this anywhere, right? So very broadly speaking, so this some mathematicians may not agree. So there is what is called pure mathematics and there's what is called applied mathematics, right? So you can. So what do we mean by that? So roughly speaking, this is mathematics. Well, it's a very crude definition, but where you can maybe call it abstract mathematics, right? So you deal with uh, I'm calling this abstract mathematics because you deal with things which are not perhaps really out there in the world. Okay, so what do I mean by that? You deal with say complex numbers, right? So or I don't know if you have come across complex numbers, but let's say you deal with uh, some set, right? I'm just defining some set. Let's say root 2, uh, say pi, and So this is set of two numbers, root 2 and pi. Okay. So where does this exist in the real world? The set, does this set exist anywhere in the real world? This collection of objects called root 2 and pi. Okay, so for someone who is of a very practical nature, who has a practical bent of mind, will not really appreciate what mathematicians are doing with this set. Okay, what is the use of having even defining this object? What is the use of allowing something like this to exist? Right. So that is kind of what we call abstract mathematics. Right. So the other part is more interesting to many of us, which is, if not interesting, at least it makes sense, right? It's applied mathematics, right? So where you apply this to something concrete. Okay, so you very simple example would be, all these word problems you would have done at school. So some car is going at some speed, and average speed is this much, time taken is this much, how much distance did it cover? Okay, so simple arithmetic. So speed into distance, sorry, speed into time equal to distance or whatever, right? So speed is distance by time, and you use that formula. So this is more of a, I know certain formulas, I apply them, and I get some result. Okay, and these formulas involve say physical quantities, right, or something that I can relate to. So speed is something that I can understand. It's not pi, right? Speed is not the same as pi. I can understand what is speed. I can understand what is distance. So, and formulas make a lot of sense to me. Okay, so this is one side of applied mathematics. The other one is, of course, the the idea of algorithms, right? So this is, okay, I'm mixing a lot of terms together, but you must forgive me for that. So maybe I should call this computational mathematics, right? So where the whole idea is about computing things, right? So an example, you'll see a lot of this in this course, where we will do a lot of things which are at the end of the day just algorithms. Okay, what is an algorithm? Algorithm is just a sequence of steps, right? So if you look at most of the math that you have learned, it will fall under these two categories. It will be either some kind of, so I'll maybe I'll not use I'll remove this applied mathematics, and I'll just put these two, right? So it's either of the pure kind or of the computational kind, right? So when I say computational, so you'll look at your Maths-1 exam, and you'll see a lot of this, right? So find the derivative of this function, or find the number of zeros of this polynomial. So if I say find the number of zeros of the polynomial, you know a sequence of steps that you have to follow, right? So that's what I mean by an algorithm. So for example, uh, if I say x square minus 6x, or rather minus 5x plus 6 equal to 0, right? Now if I tell you to solve for x, what will you do? Let's see how much you remember what you studied in polynomials. So what will be the answer here? Yeah,
X is 2 and 3.
yeah. So you'll follow an algorithm, right? So you'll follow. So what do I mean by an algorithm is, you will first, so either you can substitute a formula, that minus b plus or minus formula, or alternatively what you could do is you could say, okay, I have x square with me, and then I split 5 as 3 and 2, okay, plus 6 equal to 0, and then I split, I take x common, and then I say x minus 3, and then I take 2 common, and I say x minus 3, and then I say finally all leads to x minus 2 into x minus 3 equal to 0, therefore x is 3 or 2. So what I did just now, okay, is what you also would have done, I'm hoping. So what is that? It's a sequence of steps, okay, and you're computing something. So what are you computing here? You're computing the zeros or the roots. I don't know which terminology you're used to, but you're computing the zeros or roots of a polynomial, right? This seems like a sensible thing to do. It's like fairly clear in your head what is happening, and there is no problem in doing this.
Yes, sir.
Okay, so this is computational math. This is what I mean when I say computational. So it's of the computational kind, where you either apply a formula or you follow a sequence of steps. Okay. Now, fortunately or unfortunately, this course, right, is going to involve a lot of what we call abstract mathematics. Okay, so where you will be defining certain objects, Okay, and to begin with, you may not understand why we are even working with these objects, right? So there may not be an explicit formula out there. There may not be a very clear algorithm to begin with, but then that is the nature of abstract mathematics, right? So uh, this is the first exposure. So linear algebra or Maths-2, right, will be the first exposure to this kind of abstract mathematics. Okay, so I'll maybe just call this. I don't even want to call it pure mathematics because others may come and mathematicians may come at my door and start banging it, right? So they may be offended by that statement. So right. So what I want to insist is this might be very different for a lot of you, and it is all right. Okay, so that's what I want to mention at the beginning, right? It's okay to not understand certain things to begin with. You might have the feeling that uh, a lot of these things are arbitrary and there's nothing tangible or physical to relate to, but I would request you to hold on, right? So hold on, so go slowly. Thankfully, a lot of the course involves algorithms. Okay, so and so once you understand these algorithms to begin with, you can get some kind of an idea of what is happening. Okay, so it may not be very simple algorithms like this, right? So here it's just one polynomial and it's all very clear what is happening. But in the actual course, it may in Max 2 it may not be such a simple algorithm. Algorithms will be slightly more complex. Okay, so I would request you to stick uh, to be a little more patient and if possible invest a little more time and make sure that you don't get overwhelmed by looking at the content, which is going to be slightly different. Okay, so this is your first exposure to abstract math. All right, so that's all I had to begin with. Any questions from anyone?
Sir, with this abstract mathematics, do we mean that we will prove everything and build from the scratch, like how these formulas are made?
Right, so there will not be, so we'll try to prove things once in a while, but it won't be all about proofs. So when I say abstract, yes, there is the idea of proving things is also a part of it. But what I mean by abstract is that the objects that we'll be dealing with, right? So they are not necessarily going to be concrete things. So for example, we'll be dealing with an object called a vector space when we come to week 3, right? So week 3, week 4, we'll be introducing what is called a vector space. You have seen vector spaces before, right? So we have all seen vector spaces before, but you have not called them vector spaces. Uh, so this will be a very abstract object, right? So it's like abstract means what? It's not physical, it's not tangible, right? It's not like a football or uh, something that you can see and hold in your hand and really try to appreciate what is happening, right? So this will be a bit. Yeah, go on. Yeah, go on.
I don't know, sir. Aman Raj was saying something to me and he is muted suddenly.
No,
Okay.
I was saying a lot of background noise started
Okay.
coming from your side.
Yeah.
So
Yeah,
ask
go on.
question and then
Okay. Anyone else? Does anyone else have any other question regarding?
You were saying something about Python. That time there was some network issue, so I didn't listen that. Could you repeat that, please?
Yes, you can implement many of these algorithms using Python, so that is also possible. So that is one way of exploring things in the course.
Okay.
Okay, so yeah, so that is all I had to start off. So what I'll do is from tomorrow we'll get started with the lecture. So I'm going to call these things lectures, right? So they are live sessions, but I'll be calling them lectures. So that'll be from 3 to 4 on Tuesday, Wednesday, Thursday, and there'll be one by on Sunday, right? And that will be from 8 to 10. So more details we'll share them with you as time goes by. So maybe 1 or 2 days I'll share all the details. Okay. So any other questions? If not, we'll close the orientation. Others, yeah.
Yes, sir. So, my question is: does these all lectures of these linear algebra and the multivariable calculus are enough for the GATE DA?
Gate DA. Okay. So for Gate DA, you may need little more, right? You may need something from machine learning foundations also. So there's this concept called eigenvalues and eigenvectors, which we don't cover in our course. But Gate DA will also involve that in the syllabus. There's something called singular value decomposition, couple of concepts from MLF, which are not a part of Maths-2. So this alone will not be enough, but you may be able to solve most of the questions with your knowledge from a Maths-2, acquired from Maths-2.
Oh, okay, sir.
Okay. Any other question? Anyone?
Yeah. So,
Sir,
one more question, please.
Yeah, go on.
Sir, the link for the book is given
Right.
on the supplementary content. So, is that book is sufficient? Because there I have seen the contents. So,
The book is for 8 weeks, right? So this is a linear algebra book, right? So this will not cover multivariable calculus, but multivariable calculus is not too hard, right? So the tougher part is LA, linear algebra. Multivariable calculus is not that tough.
okay.
So yeah. Okay, go on. If there are other questions, you can. Kiran, you can maybe go ahead with your question.
sir, this session is showing at 9:30 a.m. in calendar.
This session is 9:30 a.m. If
Yeah,
you're from,
showing wrong time.
are you from India or you are
India.
okay? So this your calendar set to Indian Standard Time. So have you checked that? Because for me it's not showing only 3 to 4. It should be some Google Calendar setting.
Um,
Change in the setting, time zone, the calendar setting you can change.
Yes, sir.
Yeah.
Sir, can you please provide the link of the book? I don't have the book.
Right. So book. mm, does anyone have the link right now with you? So it should be. So you have done the course already, right? So if you have done the course already, you can go back to your uh, whenever you did the course, right? In completed courses list, it will be there.
Okay, sir.
Thanks. Yeah. So Aman has shared it, so you can take a look at that. So any other questions? If not, we'll meet again tomorrow at 3 o'clock and start with vectors and matrices. What we'll start with
Sir,
tomorrow.
master folder is not available in dashboard. I mean, in the course page.
Right. Yeah, I'm yet to add it actually. I'm yet to add it. Yeah, so I'll add that and by tomorrow mostly. So okay. So if there are no other questions, then we can meet again tomorrow. Okay. Yeah. Thanks, Sevil.
Thank you, sir.
Thank you, sir.